So xy becomes yx. So literally with 2, 3, it's now 3, 2. That's it. So let's think about that. What could that look like as an equation? As an equation, they can go y equals f negative 1 x. I just want to show you here. See, we have them here. I'm just rewriting over here. So they can have f negative 1x. Oops. They can have x equals f of y. Say the inverse. Instead of giving you an equation, they can ask for the word the inverse. The other thing they can say is reflection in the line y equals x. Reflection in the line y equals x. Now, if it reflects in the line y equals x, what is the same on that line? Y and x. So if I swap them, and they're the same, I have the same point, correct? So if like 1, 1, I now have 1, 1. So what would they be on that line? Invariant. They'd be the same. And the line y equals x, remember, it looks like this. 1, 1, 2, 2, 0, 0, negative 1, negative 1. And all the decimals in between. What people forget is it's not just those whole numbers, 2, 2, 3, 3, 1, 1, negative 1, negative 1. It's also 0.5 and 0.5, 0.25 and 0.25, 0.666666 and 0.666666, right? It's all those decimals in between. So if you want to find where the invariant points are, you draw the identity line. This is called the identity line as well. And you count how many times it crosses. Okay? I'm just giving you some pre-teaching before the lesson starts, so the lesson isn't overwhelming. You know. So if the x's and y's switch, are there things that are correlated to the x's? Is there anything that, like, if I have x's, it happens, it affects this. If I have y's, it affects this. Domain and range. So, if I go f of x, which would be my original, and I do x equals f of y, which would be my inverse, we agree? The domain of the original has x's in it, correct? Is that true? Those x's are going to turn to what when I take the inverse of it? They're going to turn to y's, and what's y? Range. So if I know the domain of my original, I actually know the range of my inverse. So an example would be if this was x such that x is greater than or equal to 2, xer, I told you the x's and y's switch, correct? So now that all those x's are going to turn to y's. So it's going to be y such that y is greater than or equal to 2, yer. So would I actually have to find my inverse graph to know the range? No, I just need to find the domain of my original, and I'll have the range of my inverse. Yeah? Okay, then my range of my original would be the what? The domain. There's some other things that are tied to x's and y's. Like, for example, my x-intercept. So if it's an x-intercept, it's a variable, I could say like x, comma 0, correct? My coordinate would switch. So what would it end up being? The coordinate switches and my x's turn to y, so it would actually be the y-intercept. So it'd be 0, comma y. Right? And then inversely, the y-intercept, bless you, would become the x-intercept. So technically, if I'm asked for the range, the domain, the x-intercept or the y-intercept on the inverse, do I actually have to find the inverse? No. I need to find the opposite on the original. Correct? And then state it. Does that make sense?
Please excuse the interruption. Could we please?
The graph of y equals f of x equals x minus 5 squared is shown. Technically it's not. We're going to draw it. So it is the original graph 5 to the what? It's the original x squared parent function 5 to the what? Right. Correct? So this is just 5 right. Yeah, if x the x was the opposite way. So we're at 0, 0 normally, so we're going to be at 5, 0. We're at 6, 1 normally, or we're at 1, 1, so we're going to be at 6, 1, 4, 1. We're normally at 2, 4, so we're now going to be at 7, 4. And then we go 8, 9, 2, 9. So why can I sketch this so easily? Because I know the coordinates of the parent function of x squared. And I just shoved them all 5 right. Correct? So that's why I say the parent function, knowing the parent function of all the different graphs we're going to look at, will make your life easier when you do transformation. Am I pushing the parent function of x squared right now? No, you should know it from 11. But we're also doing in polynomials next. So I'm not that crazy about it. But from last year, you should have known what your x squared graph looks like and done transformations where you moved that graph. Because that's the only graphs you moved last year. Okay. We're going to bypass A wherever. We're going to ignore that right now. We're just going to talk about how the heck would I sketch the inverse. So when I hear inverse and I am moving points, let's think about that. When I move points, up point, graph, what do I use? Always. Mapping, every single time. Inverse mapping is the easiest because it's just xy becomes yx. You can't screw it up unless you start negating things that aren't, like, some people think I have to swap it and then negate them. No. Swap. Okay? So I'm going to take 2, 9, and it's going to become 9, 2. And I'm going to plot the different colors. And we should say x scale 1, y scale 1. Oh, goodness. All right. So we have 2, 9, and then we have 3, 4. It's going to become 4, 3. And then we have 4, 1. It's going to become 1, 4. And then we have 5, 0, which is the next intercept. It's going to become 0, 5. Which is a y-intercept. And I have my first half of my graph. And I keep going. I have 6, 1. It's going to become 1, 6. And then I have 7, 4. It's going to become 4, 7. It's not 4, 7. Uh-oh. And then I have 8, 9. It's going to become 9, 8. What does that graph reflect on? Remember, it reflects where it stays the same. Where do they stay the same? Okay. When y equals x. So, if because it's not part of the graph, it's actually just, I'm going to do dashed lines, but here, 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 here. So I'm going to put these dots on the crossovers, but remember it's everywhere between there. So I'm just going to extend them as dashes. So how many invariant points are there? This is the line y equals x. How many invariant points? 2. And the graph?
Excuse interruption, could all grade 10?
All right, so it crosses here and both graphs are there, correct? And it crosses here and both graphs are there. Do you see how that's not directly on a cross point? It's like not right in one of those cross points, like a whole number. It's still invariant. Yes? So I'm going to go a little dot here and say these are the invariant points. Make myself a little legend. So, right now we're doing that. Right now we're doing that. Not this. Right now we're going to do it.
Oh, okay.
A says write an equation that represents the inverse. So with the graphs particularly, you wouldn't have been able to, right? You'd have to just sketch. You'd have to determine the equation of the inverse in order to be able to put it in. Okay? So here we have the graph of this. I'm going to tell you right now, determining the equation of the inverse is ridiculously easy. But no one remembers how to do it and writes sorry beside it on the test. I remember doing this, but I don't remember how. I'm sorry. It is a really easy thing. So it is bothersome when you write, I'm sorry, because it was like an easy mark that you just handed off. So what is the rule? Well, our original is technically y equals x minus 5 squared. When you see this, you should think inverse, correct? There is one thing that should immediately pop into your head when you think inverse. It should be x and y switch, correct? Inverse x, y switch. Like if I walk up to you on the street and I'm like, inverse, you should scream back at me, x, y switch. Like I should be able to find you anywhere, scream it at you, and that's what you throw back at me. Yeah? Yeah. Your parents would be like, what is going on? But that's fine. It's all good. Or your friends. Okay. So then you get to the equation and you're like, I don't know what to do. And I'm like, it's an inverse. And you're like, yeah, don't know what to do. Like you just aggressively yell back at me. Like, it's an inverse. Like, yeah, okay, cool. Don't know what to do. So let's think. If I say inverse to you, you should say x and y switch. So what might you do? Yeah, flip the x's and y's. You guys don't get the first step. You're like, I remember being taught this, but I don't know. Inverse, x and y switch. Inverse, x and y switch. Yes? Switch x and y. Switch. So our first step is to switch our x's and y's. So we get x equals y minus 5 squared. You actually now already have the inverse equation. Problem is, how do you put that into your calculator? You don't currently. What do you have to do? Get y on one side, because we only have a y equals button that we type the rest in, correct? And often on multiple choice, they're going to have it in y equals. So, we have to keep going. This is literally the hardest part, though, remembering this step. No joke. If I can get people to swap the x's and y's, they're like, okay, and then they just keep going. But they just stare at it, and they're like, I don't know what to do. They do nothing. Inverse, swap x, y. Okay? So, how do I get rid of the squared? Because I have to get rid of the exponent before the bracket, right? Square root. And when we take the square root of anything, what must we remember to do? Plus or minus every single time. Now, guys, paying attention, because this gets, you guys do this poorly in grade 12. So, if we have y equals root x, and I gave you that equation, People are like, oh my goodness, what silly people. They forgot the plus or minus. And then you guys put that there. No. No, it was just positive. You can't just do that because you feel like it should have a plus or minus for it. When you put a plus or minus in front is when you physically, your own hand gets rid of a squared. Correct? Like I'm getting rid of a squared, so I physically square root. And if I physically square root, I get a plus or minus sign. Yes? If you're copying down something that already exists, you don't get to just add stuff because you want to. Okay? All right. So I physically took the square root, this canceled, this canceled. So now I have y minus 5 equals plus or minus root x. Now I wrote the y minus 5 on the left because I like having my y's on the left. You could have left it on the right. If you choose to swap it to the left, you just take whatever's on one side, put it on the other, whatever's on the other. Don't change signs or anything, right? You just swap them. Yeah? And now I need 5 by itself. I'm going to add 5 to the back. It does not join. Oh my goodness.
Please excuse us. Thank you.
It does not. Okay. It does not. I forgot what I was going to say. Please excuse me. You interrupted me. I'm interrupted. Doesn't go into the square root. Thank you. Not just a pretty face. Yeah. All right. So, go to your y equals. Trick question. Where's the plus or minus sign? Does not exist. So, how could we put this in? Yeah, so your original y would have x minus 5 squared, correct? That's your y1. Your y2 is going to have root x plus 5. And your y3 is going to have negative root x plus 5. Now, guys, when you say negative, you have to pick the negative button. People will go subtraction root x. You can't do that. If it's a negative sign, you have to press the negative because that's a multiplication of 1, negative 1. If you pick subtraction, it's not. And your calculator will not do the same thing. Type it in. You should get this onto your calculator. If you wanted the identity line, you could go y4 equals x, right? And then you have the exact same graph in front of your face. So you would technically be filling in 4y equals. y1 is your original. y2 is just this positive square root x plus 5. y3 is negative square root x plus 5 to get the inverse graph. And then y4 is just equal to x to get the identity. Yeah? Punch it in and see if it matches. Get it to work? Okay. We mark the invariant points. Where do they exist? They exist on y equals x. Okay. And how does the graph of y equals f negative x compare to the graph of y equals f of x? What's happening? The x and y's flip, switch, whatever you want to call them. Bless you. Bless you. Okay, so you're going to take this original graph. If you take more coordinates, more accurate, but you have to take at least one off each arm in the vertex, correct? And so first off, before you even change this to an inverse graph, I want you to state the domain range, x-intercept and y-intercept of the original, please. So go quickly, domain, range, x-intercept, y-intercept. What's the domain of this function? What's the domain? X such that x an element of the real. So what's the inverse's range? Y such that y is an element of the real. Do you see the same thing? What's cool about integral notation is there aren't x's and y's in it, correct? So if this one's negative infinity, infinity, this range is negative infinity, infinity. Right? Domain's range, range domain. I can answer all these questions without graphing that graph. Okay. The range of this one is 4 or less. So it's going to be y such that y is less than or equal to 4. Y is known to the reals. It's less than or equal to 4. So it's negative infinity to 4. Square bracket. So the domain of this one is x such that x is less than or equal to 4. XER. Negative infinity to 4. The x-intercepts of this graph are negative 4, 0, 1, 0. So those are going to be my y-intercepts because the x and y are going to switch. So it's going to be 0, negative 4, 0, 1. Right? X becomes y, y becomes x. They switch. Do we agree? Okay, then our y-intercept is 0, 2. So we're going to end up with an x-intercept on our inverse of 2, 0. Do we agree? Did I have to graph the inverse at all to answer any of these questions? No, so you only have to really graph the inverse when it asks for the inverse. Or it asks for the equation of the inverse. Other than that, you never have to graph the inverse.
Yeah, it does say sketch the graph.
So, if all we are asked to do is these things, we do not have to sketch the graph. Talma. I believe in you fully. I remember the karma of yesterday. You are amazing. Everything you say is awesome. Yesterday backfired. Okay. All right. If I have to label the inverses, do I have to draw the graph?
Yes.
No. Your inverses land on what line? The identity line. If you just draw the identity line wherever it crosses this graph, it's going to cross the inverse graph. So technically, people will tell me it has 1. But guys, is it only going to have 1 invariant point? This graph eventually is going to cross it as well. So it actually has 2. Most of the time on the diploma, they don't like make you have an invariant point that's like going to fall off the graph. So this one would be way more mean. But you can see how it would be 2. And they would make you label it if it literally doesn't. I just want to prove a point that you can't label the second one. Okay? There are 2 invariant points. Now, we can sketch the graph because it actually asked us to, which Callum so boldly pointed out, which was completely correct. So we are going to sketch it. But my point is, I didn't have to sketch it for the invariance, for the domain, the range, the x, the y. Correct? You can, to guarantee that you did right, but you don't have to. Okay. So I have negative 4, 0. I'm going to have 0, negative 4. I have 1 and negative 1 and 4. I'm going to have 4 and negative 1. And then I have 0, 2. It's going to be 2, 0. That's my y-intercept. And then I have 1, 0. 0, 1. I'm going to take this little purple mark I put on here so you don't forget. And that's my inverse. Oh, wait. It crossed through the invariant point. Oh. Be still my heart. Okay. Flippy, flippy. The pagey. All right. If this wasn't a Friday, we would do this, but it is. So, this one. Last curriculum outcome of this unit. curriculum outcome states to me that I have to teach you how to restrict the domain of the original function so the inverse is a function. What the heck does that mean? I need some paper. I'll grab some. Yeah. Okay. So, everyone paying attention? Okay. So a lot of the graphs that are going to cause us problems are basically double-armed graphs of some sort. So like absolute values have double arms, right? A quadratic has a double arm. A J, if it was a J graph, that wouldn't work either. So basically any graph that if I draw a horizontal line through it, it's going to cross more than once, isn't going to work. Because if I had this graph, that's an eraser. If I had this graph, it passes the vertical line test, correct? So the original is a function, yeah? How could I test if the inverse is a function? Remember the x and y's are going to switch, right? So all these vertical lines I would test as what to see if the inverse was a function? Horizontal. So I put a horizontal, fails. That graph is going to flip on its side, yes, when I do the inverse? So this is actually going to be a vertical line on the inverse, correct? And that fails, right? So if I draw...
Please excuse me, your picture taken. Thank you.
So if I do a horizontal line, you should write this on the back of your booklet. Horizontal line, you should write this on the back of your booklet. Horizontal line test on the original. Tells if the inverse is a function.
What you just did.
I'm way nicer when you ask questions. What is the horizontal? And what you just did? You'd be like, what's the horizontal line? I'd be like, okay, guys, once again, this line that's horizontal is the horizontal line test. So it fails if when you draw a horizontal line on the original and it crosses through more than once. So if this was my graph instead, if I drew horizontal lines through that, it would pass, correct? And if I drew vertical lines through it, it would pass. So the original is a function and the inverse is a function, right? If I had this, like an absolute value graph, the original is a function because when I draw vertical lines, it passes, correct? When I draw horizontal lines, it fails. So the inverse isn't a function, right? So the horizontal line test tests if the inverse is a function. Because the horizontal line on the inverse is all horizontal lines are y equals lines, correct? What's that going to become on the inverse? An x equals line. It's going to run a vertical line test on the inverse without having to draw the inverse. You get what I'm saying? So this is, say, y equals 4. Well, on the inverse, that's going to be x equals 4, which is a vertical line. So I'm running a vertical line test on the inverse without having to draw it. That's the catch. It's my lazy way of doing it. So if I run a horizontal line on my original, that's actually a vertical line test on my inverse because the x and y switch. That making sense? Okay. In this curriculum, I have to teach you how to restrict the domain so that the horizontal line test works. Here's my parabola. Get ready. I'm restricting the domain. Is it now going to be a function? Is my inverse now going to be a function? If you say almost, that is no. It's either yes or no. So why isn't it an inverse yet? Because my horizontal line failed down at the bottom because I only ripped off part of the parabola. Okay? Thank you. It'll never happen again. Is it now? I need Vanna White. Is it now? She's too expensive though. I'll just do it myself. Is it now a function?
Yes.
The original is a function and the inverse is a function. So where is the best place to get the most amount of function left? In the vertex. But watch. If I cut it further this way, is it still going to work? Yes. So, could I cut it one way or the other? Yeah. Where's my pen? I'll pick those up later. So, talking about this, guys paying attention, if this was my vertex and it was at the x of 2, correct? I could cut to the left or I could cut to the right of it, yes? So options that I could have, the best options I could pick is x is less than or equal to 2, correct? Or I could pick x is greater than or equal to 2. Both of those would be good. So could both of those be an answer on the multiple choice test? No, they'd have to pick one. Yes, they're both correct, but it can't put both those answers there because they're both correct.
But I feel like pick multiple of them. You know, like some of the numerical responses.
Except I said multiple choice, and
Yeah.
so then, yeah. Okay, also options could be less than or equal to 2. So I have to pick values that are less than 2. So maybe I pick like -1. I could go x is less than or equal to -1 because it would only get this arm in this way, correct? Yeah? Or I could pick x is greater than or equal to what? If I pick 1, would that work? I have to pick something on because if I pick 1, I still have that j going, which doesn't work. 3, 4, 5, 6. You don't want the j. My brothers are Jeremy, Jesse, Jamie, and my dad's John. And their middle names are all John. I do not joke. You are welcome.